Hello and welcome to the answers to assessment number 9 from the fall of 2019. Right now what we're looking at is number 1. We're going to identify the coefficient. The coefficient is the number in front of the variable. That's the 15. The term is the entire thing that is here. It's not separated by any plus or minus signs. Exponent is the number that is raised above the variable. That is our 8. And the variable is always the letter. And the letter in this case is W. On part B of this question, we're looking at the 2 does not have an exponent, or an exponent of 1 if you want to go that route. X has an exponent of 3, so there should be 3 x's, but only 1 2. And then only 1 y as well, so what the mistake is here is that we should have 2x times x times x times y. Right? The 2 is not to the third power. On question number 2, we're going to distribute the negative 2 first. And when we distribute the negative 2, we end up with negative 8c. Negative 2 times negative 3 is a plus 6. And so the mistake that gets made here is when we have 6c minus 8c, we end up with negative 2c, not negative 2x. And so negative 2x should be negative 2c. And we should have a plus 6, not a minus 6. So we're going to change the minus 6 to a plus 6 in our answer. On the back side of that page, we have question number 3. In this case, we are identifying it not as linear, but because it's to the second power, it's quadratic. All right, it is true that it's a binomial. There are 2 terms. The leading coefficient is the number in front of the biggest exponented variable, which means the biggest degree, negative 7. And the constant in this case is not positive 1, but rather negative 1. So the constant of 1 is going to be negative 1. For the bonus, we need to distribute our 9 and our negative 4 through. We end up with 9n plus 63 minus 12n plus 24. That's the key thing I'm looking for here, basically. And then when you combine like terms, you're going to find that you get negative 3n, but you should get a plus 87, not a plus 39. However, I did not necessarily take points off if you simply matched what I had here. As long as you had the plus 24, I gave you credit for that one. On question number 4, we have a multiply by 5 and an add by 3. We're going to get rid of the add first. So we subtract 3 to both sides. End up with 32, and then we divide by the 5, and we get an answer of 6.4. In question B, the first thing we should do is, or one of the ways we can do this, is to divide by negative 4 to both sides to get rid of the multiply by 4 because the plus 6 is in parentheses. That's the last thing we could do. And then we would subtract 6 to both sides in order to get to our final answer of x equals negative 16. If you wanted to, early on, you could have distributed the negative 4 through and worked the problem out after multiplying there, similar to what we did with letter A. Question number 5. On question number 5, first thing we're going to do is we're going to multiply both sides by a negative 3. And when we do that, we end up with 5a plus 20. What's on top is the negative 3's on this side cancel out. 30 times negative 3 is negative 90. And then when we work this thing out, we're going to minus 20 to both sides. And then we're going to divide by 5 to both sides. And we take negative 110 divided by 5, we get negative 22. When we graph that, we're going to find negative 22 on the graph. Solid circle because it's equal. Over here, we have a divide by 8 and a plus 4. We need to get rid of the plus 4 first because it is not over the fraction line. So we minus 4 to both sides to start with, and then we will multiply by 8 to both sides to get to our final answer. Multiplying by a positive 8 does not flip the sign, so we end up with an m is less than or equal to 96. Closed circle because the equal part. M is smaller than 96, so we go to the left. On number 6, we're going to distribute the 3 through. We end up with a plus 30 and a minus 6x, along with the x and the minus 15 that were already there. All right. we combine the x and the negative 6x to a negative 5x, which means we're going to add 5x to both sides to get rid of the negative 5x that was there. We end up with 6x. 30 and a negative 15 make 15. When we divide by our 6, we end up with 2.5. On question B, first thing I do is I minus 2p to both sides of the equal sign, or inequality sign, excuse me, because I like to get down to a single p. At the same time on this problem, I minus 44 to both sides to get rid of the 44 as well. If you want to do them both at the same time, feel free to do that. All right, and then we'll divide by 2, and we end up with negative 16 greater than p. If you want to flip that around, it's p is less than negative 16. That's perfectly fine as well. On number 7, the first thing we're going to do is we're going to combine our x values. We end up with 4x minus 10. On this side, we end up with 3x plus 7. And when we minus the 3x to both sides, we end up with x. When we add the 10 to both sides, we end up with 17. Therefore, we get an answer of x equals 17, which means we have one solution. In the case of the middle one, when we distribute the 2, we're going to end up with 2 times 18 is 36. 2 times 2p is 4p. 8p and a minus, we're going to minus 4p to both sides to get the p's to one side. At the same time, I'm going to minus 16 to both sides to get them to the other side, and to end up with 2p is equal to 20. When I divide by 2, I get p is equal to 10, which means I do get an answer for p, and so that is also one solution. In the case of the one on the far right, the w and the 2w make 3w. We have a minus 4. We're going to distribute the 3 through. We end up with 12 and 3w. When I minus 3w to both sides, I end up eliminating the w on both sides. We have an equation that is false. It's negative 4 is equal to 12. Therefore, it is no solution. We do not have an all real numbers solution in this problem. In the bonus, remember what we do with absolute values is we write two inequalities. We write exactly what we see, dropping the absolute values. So x plus 6 plus 30 is less than 66. Those guys together make 36, so I'm going to minus 36 to both sides, and I end up with x is less than 30. For the second equation, we're going to go with negative x, the opposite of what's inside the absolute value, negative 6, the opposite of what's inside the absolute value, plus 30, less than 66. These guys this time make 24, so we're going to minus 24 to both sides, and I end up with negative x is less than 42. I have to get rid of the negative 1, so I'm going to divide by negative 1. When I divide by negative, I got to flip the sign. My x is now greater than negative 42. To determine the and or the or, less than means and, greater than means or. Since it's a less than, we're going with an and. In number 8, we're solving for b. So I'm going to add y to both sides to start with. That leaves me with b multiplied by t. So I'm going to divide by t to both sides, and I end up with b is equal to c plus y all over t. Question number 9. In this case, I need to leave the 2u plus 5 where it is. I'm going to multiply that by 4. So it becomes 4 times 2u plus 5. On this side, I'm going to leave the 4u minus 10 on its side, and I'm going to multiply it by the 3. When I do those two distributive properties, I end up with 8u plus 20 equals 12u minus 30. I'm going to minus 8u to both sides. I end up with, and I'm going to, at the same time, I'm going to add the 30 to both sides. I can do those both at the same time if you like. And we end up with 50 is equal to 4u. When I divide by 4, I end up with u is 12.5 is equal to u, or u is equal to 12.5. In the case of letter B, I'm going to leave the 3 where it is. So this becomes 3. I'm going to move the y plus 4 to this side in parentheses, of course. Leave the 5 where it is and put the y minus 4 up on this side. That way I can leave the symbol the same. If I switch the 3 and the 5, then the symbol's got to switch with it. So I need to switch to greater than if I want the 5 on the on the left side. I distribute. I end up with 3y plus 12, 5y minus 20, and I leave the sign the same. I'm going to minus 3y to both sides, and at the same time I'm going to add 20 to both sides to get the numbers on one side. And excuse me, I did just the opposite of what I just said in my answer key here. I'm going to minus the 5y to both sides, and I'm going to minus the 12 to both sides. And I end up with negative 2y. I end up with negative 32. And when I divide by negative 2, I end up with y is greater than 16. If you'd done what I originally set up here, you'd end up with 16 less than y, which would be perfectly fine. The bonus for numbers 8 and 9. We are trying to figure out when we're in the middle at 250, we want to go to the right 200, we want to go to the left 200. So we're at 250, we're going to go to the right 200, we're going to end up at 450, right? This value over here is 450. If we go to the left 200, we're going to be down here at 50. So how do I get an answer between 50 and 450? Well, that means I need to have an absolute value of x minus the value that's in the middle. X minus the 250. All right, I want to be within 200, so that's why I'm putting 200 in my answers area, and I need to be less than or equal to that value. And similar to what we did on the other absolute value equation or inequality, we wrote two inequalities, exactly what was there, x minus 250 less than or equal to 200, without the absolute value signs. Of course, we're going to add the 250 to both sides in that case. And we end up with x is less than or equal to 450. In the case of switching the signs, it becomes negative x. It becomes a positive 250, less than or equal to 200. When I minus the 250 to both sides, I end up with negative x is less than or equal to negative 50. When I divide by the negative 1, I end up with x is greater than or equal to 50. As you can see, I'm less than 450, I'm greater than 50. For our equation here, all right, we're getting $100 one time. That's a one-time fee, and that's, if you think about our linear equations, that means it's kind of like our y-intercept, if you will. All right, it's the b value. He's also going to get, Seth's mom is also going to pay him $8 each time. So that's going to happen over and over and over again. 8 plus 8 plus 8 plus 8 plus 8. Well, the quick way to do that is to multiply. So we're going to multiply 8 times the number of times he has to shovel. All right. This winter, it seems like he's probably getting a pretty good deal so far. Hopefully it doesn't get any worse. And the final answer we need to get to is 212. We do not have to solve this problem. It's not asking you to solve it. It's asking you to write an equation. Stop after writing the equation. In question number 11, the C is the one that is actually being calculated with. The one that we are calculating with actually is always the independent variable. The one that's the final answer is always the dependent variable. In this case, the independent variable is how many candy bars you're buying, and the dependent variable is how much money are you actually spending. All right, so how many candy bars you buy will dictate how much money you're going to spend. Well, how many candy bars could you buy? You could buy anywhere from, I just chose numbers 1 to 10. All right, now obviously the decimals in between, I can't buy 3.5 candy bars, so I have to skip from 1 to 2 to 3 to 4 to 5, and so on. And so if you chose a different number than 1 to 10, as long as it's reasonable, that's no problem. Now I take the answer 1 and plug it into the equation. 4 times 15 is 60, plus 2 times 1 is 2. 60 plus 2 is 62. I then plug the 2 in here. 60 again, plus 2 times 2 is 4. 60 plus 4 is 64. 2 times 3 is 6. 60 plus 6 is 66. When I put my 10 in there, 2 times 10 is 20. 60 plus 20 is 80. And so that's how I got my values for C and my values for M. In the case of our bonus for numbers 10 and 11, while it is true that if you let the oven continue to gain the same temperature every minute, so in this case it's going up 50 degrees every minute. Of course, after one more minute it would go to 170. After 2 minutes it would go to 220. After 3 minutes, and so on and so forth. All right. So will it take, how many minutes is it going to? It will be there after 2 minutes. The answer is yeah, it will, if the rate stays the same. But are we guaranteed that the rate is going to stay the same? In real life, we can never be guaranteed that a rate is going to stay the same without actually doing some testing. And we haven't actually tested this in our class. Maybe check it out with your science teacher and see if they would say that the rate of water increases at a constant temperature as you're heating it up. My guess is that it is not. That's kind of been my experience when I'm trying to boil water in order to make some macaroni and cheese or something like that. Question number 12. All right, is this a linear function? Well, the x's sure look good, right? We're going up by 1, up by 1, up by 1. All right, plus 1, plus 1, plus 1, plus 1. But if you look at the y's, we're going up 6 and then only an up 2. We just lost our consistency. Of course, then it actually ends up going back downhill again, right? Minus 2, minus 6. And so there is no constant increase or decrease by the same number. And so this is not a linear function, right? The y variable is not in an add-subtract pattern. In part B, is this a linear function? The answer is yes. The exponent on the y would be a 1, or we can say it doesn't have an exponent. The exponent on the x is a 1, or we can say it doesn't have an exponent. And so the answer is yes, this is a linear function. We don't have any other variables with different exponents on them. So the x and the y are both to the first power. We have a linear function. And of course, on letter C, it's not a straight line, so the line is not straight, therefore is not a linear function. It is a function. It does pass the vertical line test, but it's not linear. On question number 13. When we go to try to find the x-intercept, we're going to be looking at 8x is equal to 24, because remember we're removing the minus 4y. In that case, x is going to end up equaling 3, and so we have an x-intercept of 3. In the case of the y-intercept, we're going to go with negative 4y is equal to 24. When we divide by the negative 4, we end up with y is negative 6. We have a y-intercept of negative 6, and we connect those 2 points. Our slope on number 14, rise of 3. Go to the right of 2, so our slope is 3 over 2. Slope is always a fraction. In the case of letter B, when we go from numbers 3 to 18, we're going up 15. So that's my top number. That's my rise, 15. My bottom number, I go from negative 6 to 8. That's a rise of 8. Negative 6 to 2 is a rise of 8. And so that's my bottom number is 8. My y's are the rise, 15. The x's are the denominator, 8. 15 over 8. Another option you have here would be to use our formula, y minus y over x minus x. If you chose to go that route, you would have had 3 minus 18 for the top, negative 6 minus 2 for the bottom. You would have had negative 15 over negative 8, which of course you do not have negative on top and bottom. Negative divided by negative is a positive, and so we would eliminate both negative signs and get the exact same answer if you chose to use the formula. Question number 15. In this case, we're going to start out at a value of 242. So we have a y-intercept here of 242. That's our starting value. And then we're going to decrease by 22 each time. So we're going to minus 22 times the number of withdrawals we're going to have. Called that W. All right. And so the amount of money you have in the bank is going to be equal to 242 minus 22w on the graph. That means we go to 242 on the y-axis. We're going to do a slope of down 22 to the right 1, down 22 to the right 1, down 22 to the right 1, and so on. And we're going to end up making a line that goes through there. That might not be graphed to perfection, but as long as we're getting the idea of the negative slope and in the vicinity of the right values, we're good. In the bonus part, we are plugging a 1 into the equation. 3 times 1 is 3 plus 2 is 5. That's what we had, so we circle it. Putting the 2 in for x. 3 times 2 is 6 plus 2 is 8. So that one's correct, so we circle it. When I put a 5 in, however, 5 times 3 is 15 plus 2 is 17, not 13. So I say, when x is 5, the y is supposed to be 17, not 13. So that one, do not circle that one. Plugging a 4 in, 3 times 4 is 12, plus 2 is 14. That's what they suggested it is, so I circle it. Negative 2, 3 times negative 2 is negative 6, plus 2 is a negative 4, same number they got. And so we talk about this as those 4 all work, this guy doesn't. To find the parts of the equation, remember the slope is always the number in front of the x, not including the x. There is no x in my answer. Positive 12 is my y-intercept. That's the number that happens one time. In the case of point slope, the number in front of the x, not including the x, is my slope. And if you recall, our point slope is a secret formula. The negative 8 indicates that the x value, it's negative 8 next to x, the x value is the positive 8 in the ordered pair. Positive 6 next to the y indicates that we have to have a negative 6 in the ordered pair for the y. So we end up with an ordered pair 8, negative 6. To get an equation that is parallel, we need to keep the slope the same. 6 over 7 is our slope. We keep the slope the same. The only thing you cannot have in this slot, in the b value, is the plus 4. Because if we had a plus 4, those two lines would be exactly the same. They would not be parallel. They'd be right on top of each other. So I cannot have a plus 4 here. It's got to be something different than a plus 4. Anything but a plus 4. For our perpendicular, we're going to take the 6 and the 7. We're going to flip it over. We go 7 over 6. And since it was positive, we make it negative. It's the opposite and the reciprocal. And then it does not matter what you put for your y-intercept. You can put literally anything there, and it does not affect. The only thing I'm looking for in this question is, did you flip the slope over and make it the opposite? And for the final page, for our bonus, converting from slope-intercept form to point-slope form, we're going to distribute the 2/3. It's going to be y minus 7 is equal to 2/3 x minus 2. We then add 7 to both sides, and we end up with y is equal to 2/3 x plus 5. That's our answer. When we go to graph the equations, I have a y-intercept of plus 3. I have a slope of up 1 to the right 4. If you want to, I can go down 1 and to the left 4. That would work as well, right? Make them both opposites. In other words, we get this line. In the case of the second equation, I have a negative 3 for my y-intercept. I'm supposed to go down 5 and to the right 4. However, that's way off the graph. And so instead of going down and to the right, I got to go up 5 and to the left 4. Gets me to that same point right there. That point right there is the answer to my question, negative 4, 2. The elimination method. Well, to eliminate the x's, I need to get them to match at 6. But I need the bottom number to become negative. So I'm going to multiply everything in the bottom by negative 2. So I go negative 6, negative 2y, and a positive 8. When I add straight down, I end up with 7y. I end up with 14. I divide by 7, and I end up with y equals 2. In the case where I want to get my y's to match, I need to get them to match at a 9. So I need the bottom one to become a -9. So this time, instead of multiplying by -2, I'm going to multiply everything by -9. -9 times 3 is -27. -9 times y is -9y. -9 times -4 is a positive 36. When I add straight down, I get a -21x. I get a 42. When I divide by a -21, I end up with x equals -2. So my x value -2, my y value 2, that's my answer. My substitution problem. I'm going to replace y with -2x plus 6. So I'm going to rewrite the bottom one. I go 3x minus 5, exactly what's here. But when I get to the y, I'm going to put this, -2x plus 6, instead of it, in parentheses. Then I follow it up with my equal 22, just like I had before. I'm going to distribute -5, still got my 3x, get a positive 10x, get a -30 equals 22. All right? My x's, they end up making 13x. I'm going to add 30 to both sides, and I end up with 52. When I divide by 13, I end up x is equal to 4 for my answer. Once I have an answer of x equals 4, I'm now going to come back to the original equation, the first one. I'm going to rewrite it, y equals -2, but instead of writing the x, I'm going to put what it's equal to, the 4. Follow it up with the plus 6 that was there originally. When I multiply here, I get -8 plus 6, which of course is -2. So my final answer is x is 4, y -2. That's my final answer. And for the bonus, what I chose to do was to write two linear equations. And that is that when I had deal number 1, I had a one-time fee of $8.99. So I'm going to do a y-intercept of 8.99. I'm going to pay $5 over and over and over again because each additional, right? So I'm going to go 5 times my x value to figure out how many additional pizzas I'm going to have. And at this point, I have, for my deal number 2, I have a y, and I'm going to multiply that with 6x, number of pizzas I'm going to have. And so I need to figure out how to get these guys to eliminate each other. So I'm going to multiply everything by -1 in this bottom row. So I ended up with -y equals -6x. I ended up with 0 equals -1x plus $8.99. All right, so x is equal to 8.99 when I add x to both sides. Which means that when I've ordered 9 pizzas, I now have a less expensive time buying with deal number 1 than I do with deal number 2. And that is the test. Let me know if you have any questions.